So in lab 2, it asks you to create an SFML BOX2D project, which we haven't done yet in grade 11. So I'm going to go File, New, Project, and there it is there. You can see a picture of it. BOX2D SFML. It combines like the SFML graphics with the BOX2D. So I'll just call this one Lab 2, I guess. And hit Finish. And I'm gonna close this one because I don't really need it. And you'll see that this one actually has two files. One's called main, and the other is called physics.h. And inside this physics.h is a whole bunch of constants and a whole bunch of commands we can call later and use them. One's called create box, one's called create circle, one's called create polygon. There's one called create sprite, there's one called display world, there's one called set block texture, set block color, check collision. They're all pretty self-explanatory. Move body, spin, set velocity, limit velocity, get position, get angle, get speed, delete block. So we'll look at that in a bit. But those are a whole bunch of functions we can use. But for now, your program should look like this. This is like the hello world of physics right here. The hello world program for physics. Just compile it and run it, and you'll just see it's a bunch of blocks that drop from the mouse. But they have collision on them. Kind of cool, eh? Draw my name, Mr. V. Whoa! Real basic. And it's actually hardly any code, okay? It's hardly anything different from an SFML project. Let's mention what those little different things are. So it does make a window, it sets a frame rate, that's all good. It looks like it has a variable here called B2 world that creates a world. And that's mentioned in the lab as well here. SFML BOX2D. Okay, the first thing in our project our world will need is a world object with gravity. This will define our physical world in our project. The world object in BOX2D is called B2 world, and it needs a B2 vec2. So BOX2D, that library, has its own 2D vector. They don't call it vec2f like SFML does. They actually call theirs B2 vec2. Same thing though. Here is an example of a world object with a gravity 9.8 downwards. So the first question says, create a world object with no gravity. So if you wanted to do that, you would just set the X and Y gravity to 0, 0. And then your boxes, they would not fall to the ground. They would actually float. Kind of neat, eh? You could see, like, you could almost even make a game like this, you know? Or like squeeze game. You gotta squeeze someone out of a tight situation or something, I don't know. Anyways, it's kind of neat. I could set the gravity to anything I want. I could do -1 here and -1, and everything would get pulled up and to the left, maybe? My mouse button is what draws right now. It's thinking. Look at that. Ah. Woo. Just gonna put these guys here, and then they're gonna get smashed. Whoa. Okay. What else does it say? Anytime, anytime. So, let's look at this create box command here and make our own box in our code so that we don't have to rely on the ones that are working with the mouse. And we'll read about that. Let's say, the first function we will learn is the create box function. Here is the template. So it's a block variable, apparently. It's a defined object that refers to the actual object you create. World is the physical world to create the box in. X and Y are the right corners of the box. Height and width are the dimensions. And the type is the body type your box will be. By default, the box is a dynamic body, which means it responds to forces. There's also one called a static body, where the box is just completely stationary and won't move. Good way to simulate walls in a game. This option is good when simulating the ground or rigid walls. And then the last type of body type is B2 kinematic body. Will not respond to force, but may have its velocity set. This option is good when simulating moving platforms. The function returns a block object. What line of code will create a block object called B1 into your world that starts in the middle of the screen with a height and width of 100 pixels? Okay, so let's let the auto typer take over for us and try to draw this thing in the middle of our screen. Here's what you do. Okay, we have a new variable type now. It's called block. Everything we create is now called block. Okay, no matter what we make, could be a circle, could be a square, could be a polygon, could be a sprite. It's always called a block. We give it a name. Okay. What does it want me to call it? Create a block object. It doesn't have a name, so I'm just going to call mine B1. Okay? Now, that's great. There's my B1 object. Right now it won't draw on the screen though because I gave it no size, no shape, and no height, width, color, whatever. Okay? So it doesn't draw it there yet. However, if I go B1 equals, and this file here, physics.h, is filled with all the commands I can use. So one of the first commands we're going to use is something called create box. So I'm just going to type that. Equals create box. Now, any physics command, any physics command I call, I have to write the word physics in front of it, and you can see all the commands now that I can use. Okay? These are all just written by me so that you don't have to actually learn the BOX2D code, which can be kind of confusing. There's like a lot of physics ideas behind it. And you can just go in and basically I've created a set of commands that you can use that are simple to use. So the first thing it's looking for is a world variable. And we have a world variable. Our variable is called world. It's right here. Let it auto type. It'll tell you what it wants. The second thing it wants is an X and a Y. So if it wants it in the middle of the screen, I'll say 400. Y is 300, just because my screen is 800 by 600. The third thing it wants is a width. So I don't remember what the lab said, but 100 wide and 100 tall. So I'll write 100 for my width, hit comma. Now it wants a height, 100 for my height. And now there are three options for this body type. If you look here, it says by default, you see how there's an equals there? By default, any box I make will be dynamic. But later on I can switch the type if I want just by writing in either B2 static, static body. That will make it very rigid. I'm just going to put that in and we'll see what happens. It'll draw it, by the way. You don't have to use any draw commands, and I'll show you why in a second. But there's the box I just made. But watch what happens when it's static. Stuff just hits it and moves. It acts like a rigid barrier. Okay? But if I don't put anything in here, there is a default value that will set it to be dynamic. See how it says dynamic body? So I'm not actually going to type anything in, and then it'll just move along with everything else in the program. Okay. See that? It just moves with everything else. If I draw some stuff here, it'll smack into it, push it out of the way, spin it, whatever it wants to do. Kind of cool. Looks really cool. So where the heck is this even drawing if I didn't have to call a draw command? Right here. There's a command in here called physics display world. You only ever have to call it once, and it draws everything for you. It actually goes in and finds all your shapes and calls window.draw. I'll show you here. A little bit more advanced. Maybe we can talk about it later, but if you look here, it's going through everything in your world and drawing it. Render.draw. So we don't have to call any draw commands anymore, which is nice. We just have to call this once after our clear and before our display. It will, not only will it calculate all the physics of everything, it will also draw everything. So all it knows is there's this box in here and there's gravity on it, and this command is going to go through and kind of figure out where it's supposed to be 60 times a second and draw it. So it's taking care of everything under the hood for us. We don't really even need to know like what the physics equations are. We don't need to know how it checks collision. We don't need to know any of that. It all happens in this one line of code, actually. World.step, and inside of that world variable, there's tons of code, but that's all we need to know is that if we want to make a box, we just write physics : create box, and we're good. What if I want to set the color of this box? Let me see if there's a command for setting colors. Set block color. I see one right there. What is it looking for? It's looking for two things. I can see in blue it's looking for the block I want to color. What's the name of the block I just made? Correct. And then it's looking for a color variable. So I'm going to go color, and then I'm just going to pick a random color. Purple. Let me go on a color picker, and sometimes I think that's the best way to do it. So I'm just going to go color picker, because SFML doesn't have purple blended in there, but yeah, magenta, but I want to make my own. Whoa, I'm getting ad hustled here. Okay, I like this color right here. So it is these three numbers. I've got too many brackets going, I think. No, I'm good. Now my block will be purple. Where did it go? There it is. Yeah, that's purple. Cool, eh? I'm gonna make my gravity positive and see if it hits the ground, because stuff can get bouncy here. Watch, it's gonna hit the ground and bounce a little bit, I think. A little bit. We could actually set bounciness, and we'll learn about that later. Right now it acts like it loses a bit of energy every time it bounces, but, you know, we don't necessarily have to do that. So let me look at this lab. You know what would be actually cool is to, so in here, right here, if you see under this mouse is button pressed, which we learned last year, it's actually creating a box here at the mouse position of the window. See that? It's just 10 and 10. So that's what's actually drawing all those tons of little pictures. But I can't set the colors of these because I didn't name them. So if I go block something like this, right, and say like B2, then I could set them all to have a color by just calling the set color command. So I'll go physics. As long as they have the name, I can do stuff to them. If they don't have a name, then I can't call any of these functions, because all of these functions require the block name to be passed. So I'm just going to go color here, and I'm just going to go rand, and rand. And every time I draw a new box, it should just make a new fancy colored box in my screen. Yeah, but it remakes them every time, Ben, so it resets B1. It's actually a bad way to do it, because you still haven't kept track of any of them. You later on will keep track of them all in a vector so that we know where each one is and stuff. Okay. Oh, okay. Sure. With the left click, okay? Yeah, because I already have a right click. So is button pressed, mouse right. Right, like that, right? So I'm gonna put in a right click and I'm gonna change the gravity in my world. Okay, now, before I wonder how to do that, I'm gonna hit physics : and I'm gonna look to see if there's anything that would change gravity. Reset gravity, maybe. Set gravity. There's one. It needs a world variable and a 2D vector. Okay. My name is my vector. My gravity's. My world's name is world. I just need a 2D vector that will kind of be my mouse point, right? Yeah. So I'll go vector 2f. And I just want to pass it an x and a y. I'll say mouse : get position dot x for my first point, and mouse : get position dot y for my. Oh, these need to have the word window in them, by the way, or it'll get the position based on the monitor. That should set the gravity to my mouse, I think. You think? All right, let's try it. It didn't like that. I'm missing a bracket.
No, it's because you have to put what the gravity is going to be, like the amount the gravity is, right?
Yeah, but if you think about it, it. Oh yeah, okay. I feel you. Hold on. Okay, hold on. I might missing template argument. Oh, this has to be vector 2f. It might be way too big too, so I'm gonna just divide them both by 100. Let's see what happens, Benjamin. Oh, it does it the opposite way, but I think it is working. So let me just put a minus here and a minus here. Yeah, okay, that's a good idea. So you can see, you can kind of just build a game up with all these commands from physics.h. You can just build really neat stuff really quickly without having to know all about how collision works. You're just almost like using a game engine. Oh, look at that. Why isn't this one moving? Okay, hold on. So I put all these guys in, right? If I put my mouse here, some of them. How interesting. I'm going to print it out just so I can check what it is.
I think what's happening is that you're taking like the position and then it's like making the gravity that. It's not setting the gravity origin to that location.
Yeah.
It's just like making the gravity. Like,
Setting the gravity origin would be hard to do, I think.
but that's what you have to do.
I know, I just want to kind of set it so that it like... I don't think you can do it like that, where like you can't treat it like planetary, like masses attracting each other. You just have to give it a 2D vector and it'll like pull everything in that direction. Basically, it's creating an acceleration, but it won't do it to a point. But let me see what the gravity is. Oh, I don't even have a get gravity command.
lose and then I'll spend so much $100 on any. It's just nothing worth it. I'm saying. I'm not calling it.
It's -2 and 1 right now. Now it's -7 and 5. Does that make sense? It thinks this is 0, 0, so that turns it off. So I put everything here and then I turn everything off, and stuff just stays. If I push everything here, it should pull everything up. I don't know. It looks neat though. Look at that. It's raining upwards.
Is it because like you have your mouse at one spot
Yeah.
and then you click on another spot and so all the
It can only be between 0 and 6 in the X direction and 0 and 8 in the 0 and 8 in the Y direction, 0 and X. So I could do like, I don't know, +4 here or something like that, you know, +4 there and +3 here. And then it would always kind of pull it towards the mouse, I think. You guys experiment with it. Work through lab 2. Okay. Experiment with it. We are going to make a big project in this, so. Gonna crash?